that clear that last class we discussed about that what is thread and in how many ways we can create thread. So thread, as you have seen that there are differences there in multitasking and multi-threading. So multitasking, you have seen that in process level. So multitasking, it's going to be divided into two parts. One is that process level multitasking, another one is the thread level multitasking. So in process level multitasking, it's going to be supported by whom? By operating system. And thread level multitasking, you have seen that it's going to be support, you have to, so it's going to be supported by program. That means inside that program, you can implement that thread level multitasking. So a program, it's nothing but instruction, execution of n number of instructions. So this one will be known as a program. So now in a program, you have seen that in particular program, there will be n number of lines will be there. So all those n number of lines, it's not going to do the same task. So a group of line which is independent from some other or whatever that others lines will be there inside that program. So we can group all those lines into a single thread. So in a program, so like this, we'll find out that what are the different control flow is there. So it's nothing but that different control flow will be there. So each flow will treat as a thread and have seen that what is the advantage. So it will take less time. It will take less time. So we'll get that advantage of multi-threading. That means in the sense of that multitasking. So more number of work it can execute parallelly so that it will take less time and user also will use, they also will get satisfaction after using that particular program or whatever that software you are going to design. So this one is threading. So now in this threading we have seen that we can create any thread by using in program level thread. It can be used by two ways. One is that by extend thread class. Another one is by using runnable interface. So there is a class by the name of thread. So this class is there where in java.lang. And also you have seen that we have that runnable interface. So this runnable interface also it can be implemented by whom? It can be implemented by thread. So thread implements runnable interface. In thread, what are the different things is that in thread we told that in thread class two methods we are going to use. That if you have to start a thread, then what you have to do? You have to call that start method. And if you have to implement your code or the flow of that program, which one you want to implement that threading concept, on which you want to implement the threading concept, that block of code, you have to keep it in run method. So this is run method is also there in where it will be there in thread class. So that run method will be in thread class. So we are overriding that particular run method from thread class. So here you have seen that this one is that run method. So this particular run method it's there where in thread class. So from this particular thread class means, so in this one we have this particular run method. So if you'll go to this one thread implements, here in thread class we have this particular run method. We are overriding this particular run method. As you know that what is interface. In interface we will not write down any kind of implementation. We'll say that one is an abstract class also. And the method, which one will be there in an interface, that one will be abstract method. That means we can call this particular method and we can implement whatever we want to implement. So student A or programmer A will implement in one way, programmer B will implement in some other way. So that's why no implementation, no body for this particular method. If without body a particular method is going to be defined, we'll say that one as an abstract class. Now abstract class means, so abstract method means in an interface, whatever the methods will be there, by default it will be abstract method. And if a class having abstract method, so we'll say that an abstract class, or as we studied that concept of interface, we'll say that one as an interface also. So now in our program, what we are doing that we are implementing this particular, we are implementing this run method. So the code, which one will treat as a what? Which one will treat as a, what will treat as a, which one will treat as a thread or independent flow of independent code we can keep in this particular run method to get the advantage of threading by using Java. So whatever that codes will be there, so we have to keep it in this one. By default, whatever program we did previously, for example, right now, if I will go to that any, so in this one, there is one thread is there. So that particular thread is nothing but main thread. We didn't create it. So by default, it will be main thread. So now in this program, what we did that we are implementing more than one thread. If more than one thread it's required, then only we need to implement the threading concept. So two ways we can do. One is that by extending thread class. Another one is by using thread, runnable thread interface. So in main class, what you are doing, so you are just first, first you will define your own my thread class. So this is your thread class. So in this class will extend from where? From thread. So it's extending from thread. And in this thread class, what we have run method, which one must, we should implement. Now, if I'll not write this on, it's going to throw you the, so it's not implemented. So so right now not implemented, so it's not going to do any kind of work. So if you have to implement a threading concept, you have to call this particular run method, and you have to write down that piece of code, whatever you want to give it for the threading. So you have to write it inside this particular run method. So once you have implemented this particular run method, so this particular class is nothing but I'm creating my own thread class. Name of the thread class is my own thread. It's extend what class? Thread class. So this is that one way we are going to implement the threading concept by extending. So now for this class, how we can get it? So for this, if you'll create any object, so my own thread, so you can see that my own thread T1 new my own thread. So this is nothing but we are creating one thread object. So thread class object we are creating T1. T1 it's nothing but it's going to refer to whom? It's going to refer to thread. So I no need to write that implicitly. I can write it like this also, thread T2 equal to new thread. I can write it like this also. It will also create, this one is only that how we are going to create the thread. But as my own thread, it's extending thread class. Directly I can write down my own thread T1 equal to new my own thread. So both the things will be same. As we have seen that in base class, if there is any constructor is there, same constructor you have to implement where? In my own thread also. You have to implement it or not. If you are extending any class, okay, from base class, if in base class you define some constructor, same constructor you have to define in your derived class also. If you are not deriving, you will get that error. So you have seen that by using that super keyword, how you are going to access those variables also, or those instance variables also, whatever you will define in derived class, sorry, base class constructor. So these two lines is same. So that's why you may have that confusion. Don't confuse, these two lines is same. I can write it like this, or I can write it like this. It's same, my own thread, because we have written that it's extend thread. So we can write it like this. So it doesn't, it's mean that thread 2 equal to new thread. It's creating that constructor. So if this constructor you are creating, it's going to that base class constructor also. It's going to that base class constructor also. Base class is which one? Thread is the base class. So we created thread by using this line. So till now 21, line number 21, we have only one thread. So that particular thread is known as that main thread. When I want to start a particular thread, I should call that start method of thread class. Start method of thread class. Now, once I'll write this one, line number 29, I have two numbers of thread. I have two numbers of thread. One is main thread and the thread which has been created by this line. Now, if I'll write down another line, for example, my own thread, I can create multiple threads. So my own, so we'll copy the same line. I can create multiple numbers of thread. If I'll write it like this, now I'm creating another thread by the name of T2. Up to this point, it's fine, created thread, but we have not started the thread. So the thread existence will not be there. When I will enter the T2 dot start, T2 dot start. So right now we have three numbers of thread. One is that main thread, and one is the T1 thread, one is the T2 thread. So we have right now in line number 31, we have the three thread. Line number 30, we have only two thread. In this line, we have only one thread, that is that main thread. Now, what this for loop, very simple, this for loop is written into this main. So it's going to be executed by main thread. It's going to be executed by whom? It's going to be executed by main thread. Now, once T1 dot start, so it's going to this particular run method. So inside this run method, it's going to execute this particular function. So let us see that what output we are getting. So you can see that main thread 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times in for loops we have given, it has been created. So this one is the child thread, we will create two times. So how many thread has been created? So there may be two threads we have created. So that's why it will be 20. If I have to get that name of this particular thread, then what we can do that we can write down here, for example, thread, thread, I think it's already there. So I can write it, for example, plus t. So here I will define thread, one object. T if will define child thread. Yeah. So now here if you are defining T, so in this one it's not going to print. So if I have to check that name T1 dot so if you'll write system dot out dot println T1 dot current thread This is current thread only, t1 dot get name. So t1 dot get name, you can see that it has created one thread. So it will number from 0. So 0, 1, 2, 3, 4. So it numbering will start from 0. Now same way, if you want to get that, for example, t2 dot get name, you can see that it will be 0 and 1. So two thread has been created. To get that main name of that current thread, what we can write down that main thread, how we'll get it. So main thread will get it by using that thread dot current thread name. So thread dot current thread name. If you'll write, then we'll get that name of that particular main thread. So we'll get this main thread name. So thread, you can see that. So this is that our main thread. So this is that main, and this is nothing but priority. We'll go to this part, and in which group it is there? It's there in group main. So this is that how we are going to create that thread. So just to understand, so here we are creating two threads. So right now, if I will write down t1 dot start two thread, it's going to exist. In this one, if I'll write down t2 dot start, now three thread is going to exist. One is that main. By default, this thread name will be 0, this thread name will be 1. You can give that name also, we'll see those things. So this is that how you are creating threads by using this extends keyword. That means extending from thread class. Again, same thing also we discussed last class. Second way to create the thread by using runnable interface, in which we are implementing what? Runnable interface. Now inside this runnable, we don't have start. We don't have that start method. We have only run method. You have seen that thread implements runnable interface. We went to that runnable interface in which we have that run method. So we'll use this run method of that runnable interface same way to write the piece of code which on we have to handle for multi-threading or the independent flow of the code. We can keep inside this run method to achieve that the concept of or the concept of multi-threading. So we can write those piece of code inside this particular run. So whatever we'll write down inside this run, that one only will be treated. Those piece of code will be treated as a thread. So now to run inside this, before running, we should start it. Before starting, we should create the thread. So creating thread also same way. Here what we are doing, as this runnable interface, this class my runnable thread, it implements runnable interface. So we'll create the object of this particular class or an instance of this particular class. Now created that instance. How to create object or instance already you know. So once you created, the thread has not been created, because thread, it can be created by whom? It can be created by thread class only. So for that reasons, what we have to do, we have to create the thread by using the thread class. So that's why I written the thread t2 equal to new thread. And in this one, which one we are sending? T1 we are sending as an argument. So this is in runnable interface how you are creating thread. Here also same way, but we can write this line again and again. Why I'm stressing, some people may have that confused that why this line only it's working. This line will work because it extends thread class. So this line and this line's meaning will be same, because that constructor of thread class and constructor of this own thread, it is what you can say that it has been you have to define it. You have seen that while writing inheritance program, while extending a particular class, in base class you defined constructor, but in derived class, if you will not define that constructor, it will throw you the error. You have to must define that constructor where you have to write down that particular constructor, and below that constructor you have seen that how you are accessing those instance variable. Suppose instance variable, we have seen that super in bracket color and model. So color and model, it's going to come inside that one. Now another things also you can define. So by default it will inherit into your derived class. So for that reasons only we can write it. I hope so that this much is clear. Now in this one, same way thread T2 equal to new thread, it has started. So now this here up to line number 19, we have that one thread that is main thread. Once I'll write down T2 dot start, another thread it's going to create. That one is nothing but it will be known as child thread. Another thread has been created. And naming convention, you have seen that it will start from thread 0, 1 to how many numbers of thread you want to create, you can do it. And this part, it's going to be executed by main thread, and this part will be executed by if this T2 will get chance, so T2 will execute this particular code, piece of code. So we can't say that which one will be execute first, whether this one will execute first or this one will execute first. If you'll run, so we'll get the different, what you call that, we'll get the different output. So it will not be that same always, because run may be first, run main thread. So this one may be first has been scheduled by the JVM, or maybe this one has been first scheduled by the JVM. So it's depend on JVM. So I hope so that this much is very clear. Is that clear? Is that clear to everyone? So is that clear to everyone?
Yes, sir.
Okay, so now next we can go to that next concept. So also I have shown you that there are different kinds of method is there. For example, one is that set, how to get that name of that particular current thread. So this is that one method. So you can note it down what are the different method is there, or they may ask you that how to get the name of a thread. So current thread, you can get it by using the thread dot current thread, by using this one. Now to get a particular name, how you can get it? By using that get name. You can set the name also. So here you can write down T dot, for example, here you can write down that set name. So T1 dot set name, and after that if you'll write down the T1 dot get name. So you can write it like this also. After changing the name, after changing the name, so after changing the name, you can see that this one is right now hello name I have given, but previous one it's there thread one on also. So this way we can change the name of a particular thread by using that set name. So main thread also same thing, you can do that thread dot set name. You can define that particular name, or you can change that particular name of that particular thread. Is that clear? So this much is clear. Is that clear? So this thing is important in how many, what is thread, what do you mean by multi-threading, what is that multi-threading concept, in how many ways we can create threads. Two ways you can create that thread. You can write down two program and you can explain that which one is to create the thread. So this much is enough for this one. Next, coming to that point, so you know that you have the thread life cycle. So if you'll go to that, so you studied the thread life cycle in OS also, isn't it? Hello. What is the thread life cycle or process life cycle? Tell me what is that process life cycle? First state will be which one? First one will be new. Second one will be which one? Second one will be runnable. So first you have seen that how you are going to create that particular thread. So while writing itself, you have seen that first there will be a thread will be there. How you are going to create that thread? So let me go with that program flow only. So you have to create one thread. How you can create that thread? Thread T equal to new thread. So thread equal to new thread. So this one will be whom? For this one will be for new. So this one is new state. So if you'll write down new, so first step is that new state. So for this one new thread, so how we are going to create that new thread? By using that thread T equal to new thread. So like this you can create that new thread. So once you have created new thread, next step is what? Next what you are doing in program, you have to start that particular thread. So once you are going to start that thread, it's going to be inside this. It's going to be inside this which one? Inside this particular state. So that one will be known as sometimes runnable state or ready state. So hello. At what time, madam? Okay, then I will join. Okay, fine, sure. Huh? Yeah, yeah, link shared. I got that link, meeting link I got. Okay, I will join it. Okay, okay, fine. So sorry for the interruption. Maybe I have to go for some meeting. So in the meantime, whenever the call will come for meeting, so then I'll leave the room. So if you'll come back before 12:30, we'll join. Otherwise, you can leave for the day. So next, so first is that new state. So after that, you have that runnable. So in this runnable state, what you are going to do? This one is that runnable. So how you will come to this runnable state? When you will write down which one? Which syntax you will write down? T dot start, isn't it? So if you write down the T dot start, so at that time you will come to this runnable. So if you will write down this first, it's coming to that new state. So from new, you will come to this runnable and T dot start. So once this T dot start will be there, so at that time you will be inside this runnable, or you can say that one is in ready state. So this particular thread is ready to execute. So the thread is right now ready to what? Ready to execute. So if it's ready to execute, then what it has to do? What it will do? If it's ready to execute, so at that time it will go to next which state? It will go to next. You have seen that first creating thread, starting thread, and after that if it will get chance, so at that time it will come to this. It's going to come to this particular running state. So this one is that running state. So in this running state, so a thread it's going to, so you have seen that T1, we have created one thread. So once it started, after that it will come to this running state. So once it will finish its execution, so what it can do that once it will finish its execution, it will go to the dead state, or we can say that one as an stop, terminate. So whatever that states will be there. So once it's that running state, it's going to return something. So it will be reach into this stop or you can say that dead. So this is nothing but when it's going to stop. That means it's going to terminate. And this step is for which one? So this particular step is for running. To run, you have to write down t dot run. So t dot run. So this particular step it's going to run. So once you are going to call this one, so this t dot run means so it will be inside this running state. So in this running state, once it's going to finish its work, it don't have any other word. So that's why it will go to the termination state or stop or dead state. So this is that simple way that how the program flow is going, and also this one is that life cycle of thread. Now the interesting thing is that in this running state, so we told that there may be different reason that a particular thread can be blocked. A particular thread, it can be blocked. So that reason it may be, we know that there are different kinds of scheduling. Is there preemptive scheduling, non-preemptive scheduling? So there are different reasons it may be there. So for which reason it may stop. So then what will happen? So at that time, it will go to this particular blocking state, or we can say that this one is an waiting. So it will go to this. So now it will go to this particular state. So this particular state will be nothing but this state will be right now waiting state, or it will be known as that blocking state. So this it will be waiting, or we can say that a particular thread has been blocked by some other thread. So that's how we can say that one is then blocked. TKED blocked state. So once it will be in blocking state, so when it can go to this particular blocking state, so there are different functions is there for going to this particular blocking state for a thread. So in this one, few of those things is that, for example, if it will execute t dot sleep, so it will sleep for some time. Already you know that what is the meaning of sleep. So same thing. Now next one is t dot join. So this is that another. So t dot join in simple, it's nothing but sleeping. Already everybody knows that what is the t dot join is nothing but until or unless there are, for example, there are two threads is there, T1 and T2. So let me write it. So there are two threads is there. So one is that T1, another one is that T2. Another one is T1 and another one is that T2. So right now, for example, T2 is executing. If I'll write in this one T1 dot join. So T1 dot join. If I'll write it like this, so at that time what will happen? That T2 will execute until or unless T2 will finish its execution, T1 will not execute. So that one is the T1 dot join. So which particular, so T1 dot join means, so the thread 1 will join only once this T2 will finish its work. If T2 is not going to finish its work, T1 will not join. So T1 is waiting for what? T1 is waiting for T2 to finish its work by executing this line. So here we wrote this. So this is that one flow of that program. So this is that one flow of the program. This is that another line. So these are that some of the line which is in T1. These are that some of the line which is in T2. So right now T1, if you'll execute, if you'll in this part, in the T2 part, if you'll write down it like the T1 dot join, until or unless T2 will finish its work, T1 it's not going to execute. We'll see in program that how it's working. So so I hope so that it's clear. So this means there are two. Hello, joining madam, join.